we want to algebraically find all zeros and use that to express our function as a product of linear factors. So our goal is to factor this polynomial. And the easiest way to do this is using synthetic division if we have an idea of what the zeros should be. You can use your calculator to graph this to get a hint. And if you do that, that will give you something like this. It goes through like that, and you have some values here. Looking at this, here's x equals 1, x equals 2, and so on. Here's negative 2. This gives me a hint that I should try negative 2 right there, and I should try a 1/2 right there when I do my synthetic division. Now, there could be complex roots, and you should suspect some complex roots. So the graphing calculator won't give you those complex solutions. If you don't have a graphing calculator, you can use Descartes' rule of signs to decide whether or not you should be looking for positive roots or negative roots. Notice with Descartes' rule of signs, I'm just going to look at the positive ones. These signs are all positive, and then it changes to a negative. So there's one sign change, which means we know that there's going to be one positive real root. Using our calculator, we see that's going to be, it looks like it should be 1/2. Then we can use the P over Q theorem, which tells us what we should look for in our rational roots. So P is our negative 6, or our 6. It's our constant term. So we want the factors of 6, which are 1 and 6, 2 times 3, and those are the factors of 6. Then we want Q. Q is the leading coefficient, and the factors of 2 are just 1 and 2. So then we've got P divided by Q, and it's plus or minus 1 over 1, 2 over 1, 3 over 1, 6 over 1, 1 over 2, 2 over 2, 3 over 2, and 6 over 2. Now some of these, notice are repeats. 2 over 2 is the same as 1 over 1, and 6 over 2 is the same as 3 over 1. So you have 1, 2, 3, 4, 5, 6. Double that. There are 12 options of what you should try when you do your synthetic division. You could just go down this list until it works out, but I'm going to use the fact that we also have a hint, use the calculator, and I'm going to try negative 2 first. Okay, so when we do synthetic division, we've got negative 2 here, and then we want all of the coefficients of the polynomial across the top, being sure to watch out for any missing terms. In this problem, we don't have any missing terms because it goes powers of the x's go 4, 3, 2, 1, 0. So we've got 2, 9, 13, 3, negative 6, and then 2 carries down. Negative 2 times 2 is negative 4. 9 minus 4 is 5. Negative 2 times 5 is negative 10. 13 minus 10 is 3 times negative 2. 3 minus 6 is negative 3 times a negative 2 is positive 6. And you see we have a remainder of 0, which is what we wanted. What that means is x equals negative 2 is a 0, or x plus 2 is a factor. Now I've got a smaller equation. This is actually called the depressed equation. And I've got my numbers, my x's, my x squareds, and my x cubeds here. I'm going to use this one in order to look for my next set of zeros. Okay, looking back up at my graph, I'm going to try a positive 1/2. So we're going to go positive 1/2, carry down the 2, 5, 3, and negative 3, and do this again. 2 carries down. Times 1/2 is 1, plus 5, 6. Times 1/2 is 3. 3 plus 3 is 6. Times 1/2 is 3. Remainder of 0. That's good because that means x equals 1/2 is a 0, or x minus 1/2 is a factor. So what's left is a quadratic, 2x squared plus 6x plus 6. You'll notice that there's a common factor of 2 in this problem, so I want to factor that out. We're going to go 2 times x squared plus 3x plus 3. So what that means is 2 is a factor, because our goal is to find zeros in the factors, so what I'm going to do is I'm going to set this equal to 0. If you set this equal to 0 and not make a note of this times 2, you're going to lose the information about that times 2. So what I like to do is I'd like to put my times 2 out here, and now I can divide both sides of this equation by 2 and just work with x squared plus 3x plus 3 equals 0. In order to solve this, we could try factoring it, but factoring it doesn't really look like it's going to give us anything good. You could try 3 times 1, but 3 times 1, while it is 3, when you add them together, it does not give you a positive 3 there. So our next option is, how about complete the square? Well, nobody really likes complete the square, as far as I can tell, so quadratic formula it is. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, it shouldn't surprise us that when I look at what's under the square root, you've got 9 minus 12 is a negative number. We shouldn't be too surprised that we see a negative 3 here, since when we looked at our graph up here, we only saw 2 real zeros. That means we should suspect that there were 2 complex zeros, since this polynomial has degree 4. So going back here, let's just rewrite this. Negative 3 plus or minus the square root of 3i all over 2. So these are zeros. So we want them to be written as factors as well. So x minus negative 3 plus the square root of 3i over 2, and x minus negative 3 minus the square root of 3i over 2. Now you probably want to distribute that negative sign into this problem. So we've found all of the zeros, but let's read the question again, and it says express f as a product of linear factors. So we need to put all of our factors together and write this as a product of factors. So we have x plus 2, x minus 1/2, we have a 2, and then we have these two things. So 2x plus 2, x minus 1/2, and then I'm going to distribute my negative here. X plus 3 minus the square root of 3i over 2, and then times x plus 3 plus the square root of 3I over 2. So here is our f of x factored into a product of linear factors.